Okay, and according what I'm seeing, the stream should be up right now. So, hey, welcome if you are watching. If you are first time here, what I will be doing is coding the Sudoku Solver. And the ultimate goal is basically have actually a generator, Sudoku generator, but one that actually understands how humans solve Sudoku. So I kind of want to have difficulty ratings provided for me. I kind of want to interactively generate Sudokus by, coming up with fancy shapes and stuff like that. What we have right now is basic solver that does backtracking, which is quite slow, but good enough for the start. And actually the version 1, so we can solve Sudokus and diagonal Sudokus, and maybe we can solve 16 by 16. So last time I kind of got stuck on trying to rewrite a big 16 by 16 Sudoku, and clearly this will not work. Like, this is not an amazing way to represent Sudoku. So the first thing I actually want to do today is to come up with a way to read Sudokus. The tricky part is I was looking around on the internet, and apparently everyone has their own Sudoku format, but mostly it's just plain text representation where like there's either a space or a dot or some other special character for the empty spaces, and then you just get numbers. Or in the case of 16 by 16, you get hexadecimals essentially. So I mean, yes, okay, let's start with that. So we will be extending our Sudoku class, and in here we will want a read operator. And basically what we want is just skip over everything that's not a number, or basically everything that's not an alphanumeric character. If it is an alphanumeric character, we actually want to put it into our Sudoku. So, and I guess now the question is, so let's just grab, I had an example of something that would generate, yep. Okay, so here is an example of what this thing might look like. So this is 16 by 16 puzzle. I'll just put it here. It's funny that my IDE is trying to interpret this as code. So yeah, I mean, here the spaces don't matter at all, and the stars are just special characters that represent empty spaces in our Sudoku. Yeah, so this will not be that easy. Like, if I just want like a basic input, like that one would be for one specific format, or I could. I've never written the stream manipulators. Technically, that would be a solution. I could write a stream manipulator that would basically adjust the formatting, expected formatting for the Sudoku puzzle. Let's see. How do they call them? Da-da-da. Manipulators, yes. Okay, but those work on top of a stream. Can I write my own manipulators? That would be a very neat solution. Uh, okay, interesting. Okay, so there's um basically what we would do is this kind of thing. Um, so we need a manipulator. Oh, but how to? Well, almost. I have found an example of a manipulator that doesn't take parameters. Okay. So I need to actually make it a class in that case and just initialize the class. Okay, let's come back to that. But let me save this link here, as this will be useful. And let's just for now work with this format. So we want to go based on our current Sudoku size, which yes, we know the size from the data. Okay. Um, and okay, so just loop over the data and very simply, if this is an alphanumeric character, so we read one character, and then in that case, we need to do some adjustment actually, because this will be hexadecimal representation. So actually what I want is if it is a character, then I just set value minus a, and if it is digit, oh, digit, but digit will actually return. Yeah, I suspect digit will actually return things for hexadecimal, won't it? How does isDigit work? I know, so these are decimal. Okay, good. In this case, minus 1 actually, because we want. No, zeros are empty, so we actually do want minus 0. And if it is star, then we set to 0. Right, so for now this is very straightforward. Okay. But now I actually want to read from this. So oh, come on, ID, don't be silly. Wow. So I want this entire field to be a string. And I actually want to create a string stream out of this. Let's just first store it as a string. So we have our Sudoku, and then I want string stream. How is it exactly? Oh, that's the header include. Okay. Yes, the header is as stream. Okay, this is just string stream. Cool. Okay. And at this point, we should be able. Okay, let me actually change this a little bit. Or do we? Size. Okay, so we do have a constructor just creates an empty Sudoku. Good. I totally forgotten what I have written last week. Amazing. Right. So we can create another Sudoku with size 16. And we want to be basic Sudoku, and then just do and just see if this actually worked. Just write it out. Let's see. Hmm. I only have the numbers. I have screwed up something in the reading routine. Okay, let's see. What did I screw up? If it is, what does is alpha actually do? No, this should work. Ah, okay. Not minus a, but minus a plus 10. Because you want a to become 10 and not 0. Okay, that makes way more sense. And this looks much better. Okay, so but now we know for sure that this is a valid Sudoku and there are hopefully no mistakes in there. So let's just actually call it number 3 because the number 3 was a failure. And yep. And let's just try to solve it and print it out solved. Nope, our 16 by 16 solver is broken indeed. Okay, so this is, yeah, okay, so this is verification that indeed last time when I was copying the Sudoku, I didn't actually make a mistake, but I made a mistake in the solver somewhere, or we made a mistake in setting up the constraints. So let's see. What would be a good way to debug this? Okay, first of all, let's just get rid of these two for now, because these actually work as intended. Can you probably cannot like block comment a thing here, right? Yeah, anyway. Let's just do it like this. And here, just get rid of this. Okay, so now we only have the big 16 by 16 Sudoku. Right. Let's just step through the... Oh, and I already see a thing. Okay. Was that really it? Ah, stuff is happening. Okay. So yes, clearly, okay. I was very surprised that, yeah, that it explains a lot of things. So now as you can see, the solver is very, very slow on 16 by 16. It's just too much for it to handle. This might not even finish in a reasonable amount of time. So that's a good opportunity to start thinking about how to make this faster. Uh, Let me just clean up a little bit since that thing is running, and yeah, it might be too slow to ever finish, but uh, let's just leave them here. Okay. So how can we make this faster? Well, the funny thing is, like, my ultimate goal is to make this solver behave like a human. So how do humans solve Sudokus? Well, um, actually, let me just go to an example. Da, 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 da. Can I quickly find... Right. Okay, so this is just like a super extreme Sudoku. But basically, how you solve Sudokus in general, and just, yeah, this is like a completely crazy one. But anyway, the idea is that, okay, I have a 7 here. So obviously, I cannot have 7 in the column, in the row, or in the block, right? At least for like normal Sudoku rules. So if I have a situation, for example, like this, that I have a 7, 7, and let's say I have another 7 here and a 7 here, well, now if you look at basically this bottom block, where can the 7 be? So let's just switch this, right? So if I just put in 7s, right? So the 7 cannot be here because of this 7. So I just eliminate that possibility. 7 cannot be in this column because of this black 7. So this is out. In this row, I already have a 7, so this goes away. And in this row, I have this 7. So I can kind of do this kind of pruning approach and eliminate possibilities. But this kind of means that at the very beginning, like if I would have a completely empty Sudoku, like this is basically how it looks like, right? How we can implement this is just, instead of having a value within each cell, we can have an array of possibilities within each cell, which basically means we would have an array of booleans. Now, depending on the implementation, that might be pretty slow. So actually what we will do is just have a big enough number, because, I mean, if we pick a 32-bit integer, we can represent 32 possible numbers, because we have 32 bits, and each of the bits can be true or false, 1 or 0. And 32 is already pretty good. I'm actually tempted to go with 64. I mean, this will definitely... So it will affect performance, because if we pick a small integer, or like a small data, like we cannot really use a char because that one probably will only have 8 bits. But we could use like a 16-bit integer. If we keep it small, it's the entire Sudoku will better fit into our caches. So it will actually affect performance. So technically we could... This sounds like a thing that could be a template parameter where I basically limit the maximum number the given Sudoku puzzle can hold by a template parameter. Uh, yes, okay, let's do it that way. Okay. So what do we need to change? We will need a new class which will be what do we call it? Square? Sudoku square is. This one will be templated. And let's just take the, or do we take the number of bits? Yeah, let's just take the underlying type. Okay. So this one will just have the data type here. And now we want bunch of operations. So when we initialize it first, okay, let's just, yeah, I'll just take the max value here. Um, oh, not going around. Okay. So at the beginning, we just want to set, data to all once. But we actually want to set okay, this will be a little bit of bit shifting magic to get this right. Because kind of made it hard on ourselves by not knowing what is the underlying type. If I knew the underlying type, I could just simply play with constants and do it that way. But since I don't know the underlying type here, you know, need to do a little bit of magic. So what I want to do, and I haven't done bitwise operations in a while. Um, da, 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 da. Um, should okay. So what I want to set data to is starting from 0. We want to invert all the bits. We want to shift it by max value -1 and invert that. I think this is correct. So my intention is basically, let me just check if I'm not screwing this up somehow. Yes, okay. So my intention is that we basically go through these steps. I have the zeros, right? So I just do 8 of them. 1, 2, 3, 4, 1, 2, 3, 4, right? I want to invert them. I want to shift them. So let's say I shift them by 4. So it would end up being this. And then I invert it again. So I get basically ones at the number of shifts essentially, right? Oh, but then this actually should be max value. Because if I shift it by 1, I end up with 1, 0. The 1, 1. If I shift it 9 times, I end up with 9 once. Now, the only question here is, I'm not 100% sure whether shifting is actually well defined if you overflow. Ooh. Let me quickly check that. Is this well defined? Hmm. Okay, so what I'm seeing is that it should be, but they are not being very clear about that. It only says that it's undefined if the right operand is negative or greater than the number of bits in the left operand. Okay, so this should actually work. Hopefully, we'll see. We'll see. We'll test it and see. Okay, so we have a square initialized at this point. So now we need a couple of operations. So we need presence operation. We check for a specific number. So this just returns data and run shifted number -1 and if this is 1, not 0, right? So if the end returns non-zero, we know that the specific number is still set, or is still a possibility, or whatever you want to call it. So this should be is possible. Let's call it what it is. Okay. We will want to count the number of possibilities, I guess. To check that. Okay. I think in the new standard there's right. I suspect I will not have this thing yet, but let me try. So, oops, there's a new header in C++20. Oops, that's not the header, that's the function. Yeah, I don't have it. That's unfortunate. So I will need to write it myself. Yeah, so C++20 has pop count, which should be so useful. But I need, yeah, I just need to write it myself. Right. Yes. Right, and just do it this way so we don't have to do funky stuff here. Right, and then we definitely want to have, so should be const. What do we, we want them is set that will return whether we only have one possibility. We will want set value which kind of only, okay, not set value because that's very misleading. Just to value which will return 0 if count possible is not 1, Right. So, and otherwise, just return the number that's actually set. Yep. So we need to go, unfortunately, over all of them. And I mean, this should be unreachable because we check if we have only one thing and we just look forward all the things. And we are guaranteed to return. Because again, we know for sure there's only one thing. Right. What else do we need? Beautiful to have something like next. So basically, something like this. Basically, get the next possible number. This would be nice for, I mean, we can already use this in our backtracking solver. Okay, let's see. It will return 0 if there's no next. We need some actually mutating operations. So honestly, the only thing we will want to do, I think, is just yeah, okay. So we definitely will need a set. And I guess reset. We will want to return. Yeah, we will want to have a thing that can return the value to like the original set. Right. So let's have a reset. We will need a set that just sets it to one number. We will need a remove, which will just remove a possibility, and that's it. What else do we need? Like the operations are going to do, right? Yeah, I will be just removing them one by one. So remove is good enough and set to just set it to a specific number. Yeah, I think this is good enough. So yes, so for reset, we will just do the thing we are doing in our constructor. Set it to 0. And then do the bit shift magic. Then for set, we want to set data to 1 shifted by the number -1. And for remove, we want to do 1 shifted by the number -1. Oh, I think I need to do this maybe. So shifted by the number, then take the inverse of this and do an AND, yes. Okay. So we'll basically have one bit set. We just put it into the correct position and then we flip the number. So we only have a 0 at the position that we flipped it. Right. Do we need anything else? I think this is kind of okay. Right. And yeah, just FYI, like this is still running. Let me just get it. So now instead of the vectors of ints, I want to have vectors of Sudoku squares. And for now, I will just use 64 as the backing type. Right. Yep. And I need to adjust my checkers. Block checker. Because now this will not be pointing to integers, this will indeed be pointing to Sudoku squares. And actually I need to clean up a bit. Okay, let's move it into separate ink. Yep. And I was looking at the block checkers. So here I need to include Sudoku square. Oh, and I definitely need to add it into my CMake file. Right. So this will be Sudoku square. Okay, and the same thing needs to happen here. Not just missing stuff, right? Like, need to start that. I Yes. Oops, what was that? Um, okay, that was weird. What just gave me a notification? No, anyway. Um, so here I don't want to check if it's a zero. I want to check if not. Okay. If it's not set, we just ignore it. What is it complaining about? Uh, oh, ah, okay. Silly me. It needs to be public, of course. Right. Um, so if it's not set, just jump over it. If it is set, then we want to get the value. Right. And if we have already seen the value, then we are just done. And otherwise, yep, we want to do this. Okay. What is it complaining about? Oh, because this is things changing. Okay. So this should be fine. So block checkers are good. What do we have in Sudoku? Do we have anything in Sudoku that we need to adjust? Da. Uh, okay. This needs to be Sudoku square. This needs to be a Sudoku square. This needs to be a Sudoku square. And this needs to be a Sudoku square. Right, when writing it out, I want to get value. Did I do value? Yes, it's written 0. Yeah, so that actually works great. When I'm reading it, set to the value. Okay. And last thing I need to adjust is actually my solver. And okay, now these are of course completely broken, but I will not be fixing these because that would be silly. And to be honestly, right now only care about the big one anyway, because that one is really stressing our solver. Okay. So we need to change our find empty. So now we don't want to do find empty, we want to do not set. Right. Yes, but this pair now has to be... No, these are coordinates, so that's good. And the same idea here. If a particle thing is not set to specific value, there is a problem. Right. So, okay, so this has to change. Okay. So we start at a 0 and then keep asking for the next possibility. So this will go over the possibilities, and we want to stop the moment we run out of possibilities. And I think I set it to return a 0. Yes. So in that case, I want to loop until this, I think, is a 0. Oops. So while it's not a 0, then just go over the possibilities. And what I want to do here now, it's a little bit trickier. So first of all, I actually need to store the original value, because what we now we can have a situation where the square is not set, but it can have a specific value, as in it can have like a couple of possibilities. So previously we kind of just used the 0 to represent everything is possible. And that's what this line here does. It basically resets it back to the original state, as in everything is possible. But we don't want to reset it into a state everything is possible. We want to just set it into a state where it was before we started mucking with it. And actually, even this loop should be over the original, because we will be mucking with the value in this square in this loop. Because what we will do here, we will just set it to the number. Yep. And then we call solve recursive. And this will be original. Okay. I mean, technically, I think this, honestly, I made some syntax, of course I made some mistakes. Right, here I want to put in a Sudoku square that's just empty. Oh, and I'm missing a couple of more places, of course. Okay, let's see now. Uh, okay. So technically this should run, but it will not finish because okay. Something is indeed very wrong. What the heck? What did I break? Okay, I mean this doesn't even have these things. But it seems to correctly represent numbers from 1 to 9. I mean, yeah, those are all correctly set. What? Why would it not set? Okay, this is interesting. Why? Or are we screwing it up in the solve? It's also possible. Let me see. No, like this never gets set. Okay, what's wrong with this code? This is weird. This should just work. Um, oh, debugging it is. Okay, so yeah, this just goes over that. That's fine. 9. Okay. That's fine. We have a star. That's okay. Another star. Another star. Another star. Oops. I missed the C. Damn it. Shoot. I don't want the checks. I want the data. So this is was position 6. No, sorry, those are rows. Position 6 here. It did get set. What? Um. Wait, what? Why is max 9? Because I don't set max to the. Okay. Obvious things are obvious. Right. So this thing This thing actually needs to do a little bit more work because, right, this constructor needs to be with size. Right. Now it should work. Doesn't work, but at least we have the correct Sudoku. Um, this output is very annoying. Let me just change that very quickly. Um, we actually don't need the width thing anymore. If we output alphanumeric stuff, let me just set it to 2. Right. I want to do -10 plus a. Not debug. I don't want to debug you yet. Oh, come on. Okay, better. But our solver is failing hard. So let's see. Um, so let's see if I mean this is this should be correct. Well, this is not 0. We set the value and then solve recursively. Okay. Here we find the first one that is not set. That's correct. And here, if we find anyone that's not set, we just return false. That makes sense. Well, I don't see anything obvious, which means this will be a little bit tricky. Figure out. I want to go to the solver. All right, let's see. Okay, makes sense. The first one is a 0, 0. Okay. That's interesting. We immediately bumped out of this loop. Why? Next return to 0. This is very curious. I wish. I wonder if there's a way to switch to like formatting here. Somehow. I don't particularly want to like muck with I mean, yeah, the problem is I just want to see this like bits. Is that somehow possible? Uh, hmm. Um, Let me just quickly add. What was the? Okay, let's do this thing. Okay, so basically just adding a more method that can help me with debugging this thing. Because I want to basically quickly have a look at the content. Yeah, I unfortunately am not that proficient with CLI yet. I would guess that like you could. I'm sure it's possible to like see this in like in a different format. Like if there wasn't, it would be weird. Oops, no, that's not what I wanted. I wanted New watch. Yes. I want original dot s vector. What the heck? I mean, yes, it is inlined, but uh, is there a website that converts integers to bits? Uh, so, okay, this is this, which is weird. Because, I mean, what the heck? Um, I mean, this is space 00, which in our puzzle is 0. How the hell is this a 0? I mean, 16 bits would be, so this is 8. 8, so like the value would be here. Or if this is formatted weirdly, this would be here. What the heck is this in middle thing? Oh, did I screw up the initialization somehow? Okay. Let's just try this again. I take an unsigned 0. I flip it. Then I shift it by max value. This will create max value amount of zeros. And then I flip the entire thing. Could be correct. I mean, this is definitely working correctly because it returns 0 when it's printing, right? Because that's what we do when we are printing out, right? No, we actually use value. Okay. Oops. But yeah, like value goes count possible, not one, then return zero. Otherwise, write out the one that's possible. Hmm. Okay, this is so strange. Uh, hmm. Is there debugging is always fun. But yeah, this is very strange. I mean, we are using the default generated assignment operators. Those should all work just fine. This is a very simple class. Okay, I really need to figure out how to make it not be inline, because otherwise this I will not be able to debug this. Okay, I guess this should work. Where do I right? Okay, let's do this, 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 this. Okay, restart our debug. Um, so will you allow me now to try some stuff? Federal original dot. Still no? Damn it. Oh, it allows me to do this one. Okay, interesting. Um, yeah, so clearly next just returns nonsense. Well, I mean, based on the value, I'm not surprised. Actually, let's just evaluate this one. Mm, yeah, no, I mean, obviously this is working fine. This value was there. What the heck is wrong here? Might be something super obvious that I'm just not seeing. Wait a second. This is the same weird value. Um, what the heck? Our data doesn't get set somehow? Or it just gets set to some weird garbage. Hmm. Um, so I mean it has to get set to this garbage when we are loading the puzzle. Um, so what do we do when we load the puzzle? That's weird. So this is output, this is input. So we just call set. I mean, this looks okay to me. I'm just trying to narrate down to figure out where the problem actually is. Um, yeah, no, it's a serial. Okay, that makes sense. Oh, yes. I think I know what's the problem finally. Oh, just yeah, set zero, of course. What do we do when we set zero? We shift by a negative number, which is undefined. Oh, I even said this. God damn it. Oh, yes, so we have a random chunk in our. Well, it's not exactly undefined. Apparently, there's something weird happening that just. I don't know why it's returning. Consistently returning the weird number. But yes, we don't want to do that. Uh, we don't want to do set. want to reset. And yep. Oh, the joy of programming. Okay. Well, yes, this now runs and doesn't stop because we didn't improve the speed at all. We just made more data, basically. Okay. But at least we are back to our non-functional solver. I mean, our functional but never finishing solver. Okay. So what I want to do now, I actually want to test if this is working correctly with a small Sudoku that we know actually will work. Let me just get a Sudoku from a website. Okay. And this is a different format from the same website. Damn it. Why do they have different formats for like... This is so silly. People, why do you do this to me? Like two different Sudokus have two different formats on the same website. Fun stuff. Let's call it small. Yep. I guess this works. Wasn't really expecting it to do this, but I guess that's okay. I don't particularly need the new lines, but they're not really harming anything. I can do it small. I think my input operator will actually work. I think. Let me just quickly check that. I mean, yes, it will just set it to 0. Oh no, but then we are doing set 0. Oh, shoot. Or if it's a 0, and we definitely want to skip over the stuff, right? Sure, this should work. Oh, no. I think we broke our solver completely. Okay. So, what, where am I? Main. Okay. Oh, no, it was just super slow. Ah, obviously it was super slow because I did this crazy thing. Yeah, like if it doesn't get the opportunity to inline these functions and actually has to call each one of them like as a function, of course it will be slow as hell. I mean, this should be generally pretty fast if it actually inlines the functions. I guess I don't need this. Right. Oh, and I need to fix this now. Maybe that was why it was so slow, actually. Okay, let's see. Now, hmm. This is much slower than I would expect. Are we not building with optimizations? Probably not, actually. That's actually a very good point. Where do I set? Where do I set the build? Hmm. Huh. Okay, that's better, but it's still very slow. I'm actually genuinely surprised that it is that slow. Hmm. This is complaining about. Oh, because we are comparing silence and yes, indeed we are. Um. Yeah, because we have functions where we return swans at some point. Uh, but this can definitely be size T. This. And I'm returning -1 there, so that's not helping much. Yeah, okay, let's just not muck with the main for now. I could. Yes, this I can do. Okay. Um, let's put it again. Yeah, this should be unsigned. And this also should be unsigned to unsigned. Okay. It's a bit. Yeah. So okay. I'm I'm really wondering why the solver is so slow. Because this is a big performance regression from the basically the previous attempt. It could be that the optimizer cannot really optimize this recursive function anymore. Because yes, like previously. Yes, I mean previously we only had basically the iterating function. So we only had one init here. So this was for cycle like for just going from 1 to 16 or 9 based on the size of the Sudoku. Hmm. I don't think I have a profiler set up. here. So let's just write this down as like the next thing. Because I'm actually really curious, like where the massive regression is coming from. Like the bit operations, like I'm doing a lot of operations, but it's not. Hmm. But to be fair, I do have a lot more data, or do I? This is actually very interesting. What? I will try something. Let's just do let's just do this. Let's just clean up these things. Um, mm, so I guess this should be defined here. Okay. So then in the block checker, I can actually define this. Right. All right. This will be what did I call it? Square type. Okay. Right. This is cleaned up. This is cleaned up. But okay. Do I have any up here? This thing. This needs to be Sudoku block type. Then in here, yep, that would be many of these. Do we have any more instances of this thing here? Okay. Um, yeah, I guess here. Cannot really help it. I need to do it like this. Okay. And because of that, what I can do now is I can come here and try, for example, this. Oh, come on. Ah, more of these. Okay. Square type. It's okay. Was that it? Yeah, maybe that was slightly faster, but it's not. It's not the size of the data. Am I really doing so many more operations? This is so curious. Okay, next time definitely I really want to investigate this and see what actually happened, because like this is a big speed downgrade. And I really wasn't expecting such a big jump in speed. Okay, I mean, it is what it is. But now we can make it faster. Um, what's the time? Uh, oh, I have been going for quite a while already. But I kind of feel like doing one more thing. Okay, one more. I will do one more thing. So what we did was just we basically switched things around. It's doing exactly the same solving approach. It's just brute forcing through all the possibilities. But as I said, if you are a human, you would basically go and try to like figure out, oh, like, a one can be here and so on. So I want the solver to start doing that. And kind of the first thing it can do, it can actually go and prune the possibilities that basically cannot exist, right? So what I want to do at in here, right here. Okay. Actually, no. I want to do it. Mm, okay, so the tricky part here is that right now, like the only thing I'm modifying is one thing. And basically because of the recursion, like we kind of end up with a stack of these originals that we can then just like, recover on our backtracking pass back. And that basically means like everything is fine, right? But um, but if I start pruning the space, so let's say I set a thing here, Well, technically, if I do that, it means that I would also need to remember which spaces I actually managed to prune. Because I need to undo that right here. Oh, this is getting interesting. So for the simple Sudoku, this is fairly straightforward, right? Like we basically can figure out, we can figure out which blocks the disk space belongs to. And if we know which blocks this space belongs to, then we can just go over those and just say, hey, this number that we are currently undoing is now a possibility again. Yes. And actually, it's more complicated because we actually want to do that here. Because let's say from the previous loop, we removed, let's say we guessed the one, right? We removed the one in all the blocks from like all the elements in all the blocks that this specific next thing belongs to. But on the next loop, we kind of want those values back because now we are like guessing a different number, right? Like we want to reintroduce the one back into those blocks because now we are not guessing a one. And instead we want to guess something else, like a two, for example, right? So, okay, this is quite interesting. This will, okay, so probably we shouldn't start doing that right now because I've been streaming for a while already. So we should leave that for tomorrow. But what we can do, and that's totally safe, is at the very beginning, we have some preset values in the Sudoku, right? Well, we can just use those to remove the possibilities that are obviously incorrect. Because those will not be changing, like those are already preset. And we will never be guessing like a different values for those. So whatever we remove is gone forever and it can never reappear. So that's definitely a safe thing to do. So let's just do that because that's fairly easy, I hope. Okay. What do we need then? Okay, so we read the puzzle. This happens here. So then basically what we want to do is like go over all set values, get all blocks the value is in, prune all squares in that block. Right. So let's just quickly write this down. So this will be s3 data size, right? I will really need to change this interface at some point. This is super awkward to work with. And yep, size, right? Then if I guess this should be like this. If the element is not set, then we just continue, easy. Um, right, like this. So if it's not set, we just continue. That's fine. If it is set, we need uh, a way to get blocks corresponding to a coordinate. Well, we have the checks. Oh, this is nasty. So it's easy to do for like normal Sudokus, right? Because I mean, we do that when we do the setup checkers, right? So it's basically like an inverse of this. However, if you want to have like weird, if you want to have like weird block shapes, like jigsaw Sudokus, this gets quite more involved at that point. I mean, what I would actually want is to have just like a database of these blocks for each element. I mean, can I do that? Yeah, let's do that. That will be yeah, okay. That will be fairly good. The slightly tricky part is I can either do it like in a separate function. Or if I do it here, I kind of need these pointers to be stable. Which I could do. I mean, I know how many blocks I have. And technically, if I'm reading a Sudoku, I would still know that, like, it's not, like, this is not a thing that would change. Yeah, yeah, yeah. Okay. I was thinking about making these like whole unique pointers and then just get like big pointers to the blocks, but don't necessarily need to do that. I can just do very simpler thing. Okay. So in here, if based on the, yeah, this will differ based on the type. So if it's basic, we will have shoot. Okay, actually. Yeah, okay. So the number of blocks is 3 times size. So rows, columns, and blocks. If the type let's just do it this way so we get compile warnings if we eventually miss a thing. Okay. So if it's basic Sudoku, 3 times size, number of blocks. If it's diagonal Sudoku, we have the 2 extra diagonals, and that's it. So now, once I place it into the vector, I also want to record that all those, yep. So I want to have another loop here, and I will need a data structure in my Sudoku somewhere, which will be a little bit funky. So it will be double vector of unordered sets. Or what? This should be correct. Am I just being completely stupid? So that was good. Of pointers to block checkers. And yeah, let's call it block mapping. Ooh, nasty data structure. Okay. And this we want to definitely initialize in the constructor for sure. So one constructor data block mapping. I want this to be a size of vectors of block checkers that are of size and oops, no, this is vector of unordered sets of block checkers and size, and inside I want an empty unordered set. Ooh, nasty. Okay. And actually the same crap I want here. Yep. Except here does, of course, this is this way. Okay. Righto. So now now I can do this. So I can do block mapping ij insert checks dot size -1. So take the last thing and take its pointer, and this should be fine. I can already see that this will backfire at me because I'm just tying this data structure very narrowly together. Like if I ever accidentally reallocate this checks vector, I'm screwed. But that's not happening right now, so who cares? It's fine. Yeah, everything will be fine. No problems upcoming, no bugs. Like who makes bugs in code anyway? Only silly people. Yep, the same thing here. And finally, a bit more involved, but essentially the same thing here. Yep. And yep, here. Okay. Oh, this will be a little bit more nasty because I have two things. So let me just copy this again. So block mapping I and block mapping I size -1 minus I. So to this one, I want to insert the -2, and to this one, the -1. Okay. Ooh. And now I have the block mapping. So I have map of block check, right? So now I want to go to block checkers, and I want to add a prune number. Um, this technically this is cons, but I don't want to mark it as cons because that's very silly. So what I want to do, I want to go over the things that I know about. And if the thing is not set yet, because I don't want to remove it from the ones that are already have one, like that will only happen for the, like this if will only happen to be this element will only happen to be set if it is the original trigger that caused us to call this function. So actually, let's just do this. So I don't have such a deep nesting. And if it's not set, I want to remove number. So I want to prune it out. Okay. Yep. This is good. So now I will just make a function here. So given to xy coordinates and a number, just have fun. Go over the blocks corresponding to this thing and just prune all them. Okay, so that's pretty straightforward. So what we want to do? Wait, why did it? That's better. That was weird. So I need a for loop. I will get pointers. Just go over all of them and call prune. Yeah, that should be it. So now in the main, what we can do is just do test3 prune ij test3 ij data j value. Right. I guess this is kind of redundant. So let's just change this interface. Because, like, why would we specify the value if we are already giving it coordinates? It might be useful later, but sure. Okay, let's just do another function, another method that's basically the same, but it will actually use the value of the block. So this will just call prune x, y, and what the heck data x, y value. Yep, okay. So now I can just do this. And technically, this should be faster. Or not. We broke it. Fun. Oh, jeez. What now? Yeah, okay. Well, let's continue the tradition and end on a broken note. Because last stream I ended with a broken piece of software that didn't solve the 16 by 16 Sudokus. Now I can end on a note where this thing doesn't work. But that's good because that means that we have things to do tomorrow. Well, it has been fun for sure. Otherwise, I wouldn't manage to stay online. Holy crap, for 2.5 hours. Actually longer. Why is this showing such weird? Oh no, not 2.5 hours. Okay, that's the stream counter is weird. Yeah, I have been online for 2.25 hours, I think. Anyway, if you are watching this now or the recording, thanks for watching. And I will be back tomorrow with a continuation of this. And as usual, I will update the repo the moment the stream is over. See you later.